Hello, my name is Beth Dixon, and I am the Math Lab Technician and work in the Math and Behavioral Social Science building in room 222. And this is a lesson in how to solve two-step equations. It's not a lesson to replace your teacher's lesson or your teacher's lecture, but to supplement and to give you some extra practice problems to look at and to watch. So I hope these help. So let's look at some two-step equations. The first example I have is 2x minus 9 equal to 3. And as we solve these, we want to remember that first, our goal is to get the x by itself. Secondly, to get the x by itself, we're going to work in the opposite order of our order of operations. Our order of operations tells us how to simplify numbers, but we're not trying to simplify, we're trying to go backwards from what we did do to get the x by itself. So the first order of business is to add or subtract, which is the last order of operations. In this case, we have 2 times a number, minus 9, gave us 3. So we're going to work in reverse to get that x by itself. And we want to add or subtract anything that's been added to that x term. In this case, a negative 9 has been subtracted. So we've subtracted 9, and the inverse operation for that is to add 9. So we're going to take and we're going to add 9 to both sides. Now your teachers may show your work differently. We have a lot of different teachers and they show their work differently. It doesn't matter how you show it because the process is the same. And so I'm just going to continue to write mine underneath, and you can adapt it if your teacher shows it, writing it to the side or crossing the bridge or any other way. So we've added 9 to both sides. Negative 9 plus 9 cancel each other out. They add to 0. And that leaves us the 2x. That means that we've undone that subtracting 9. But what we do to one side of the equation, we always have to treat the other side of the equation equally. This equation is like a scale balance, and if we do something to one side of it, we have to balance it by doing that same thing to the other side of the balance. I also kind of compare it to having 2 kids. If I bring something home for one of them, I'd better bring something home for the other so that things remained balanced in my home. So in this case, I've added 9 to the 3 as well. 3 plus 9 gives me 12. And again, I'm just adding the like terms. So now I have 2x equals 12. To get the x the rest of the way by itself, I need to think about how 2 and x are related. 2 and x are related because I've said 2 times x gives me 12. So 2 times x gives me 12 means that 2 is multiplied with the x. So the inverse of multiplication is division. So we want to divide the 2x by the 2 so that that's undoing that multiplying by 2. And again, what we do to one side of the equation, we always do to the other side of the equation. That then leaves us the x by itself on the left-hand side because 2 divided by 2 gives us 1. Any number divided by itself gives us 1. 1 times x is x. 12 divided by 2, because we have to do what we do to one side, we have to do to the other, gives us 12 divided by 2 on the right-hand side. 12 divided by 2 then gives us 6, and that gives us our answer. Now we can check that, and we can check all of our problems. 2 times 6 minus 9 equals 3. 2 times 6 is 12. 12 minus 9 is 3. And that does check out. Now I won't check all of the problems that we're doing today, but you can check every problem that you work in an equation by taking that answer and plugging it back in for the x and then simplifying it using the order of operations. Okay, let's look at another example. 4x plus 7 equals 15. So as we look at this, the x has got something multiplied with it and something added to it. So the first thing we want to do is undo the addition. So plus 7, we want to subtract 7. What we do to one side, we have to do to the other side. And again, I'm showing that subtraction by drawing it underneath and drawing a line underneath both sets so that that looks like a subtraction. Then I have plus 7 minus 7, adding to 0, and then I can come back over here and combine my terms. The 4x is left on the left. 15 minus 7 gives me 8 on the right. Then I look at what I have left, and what I have left is 4 times x equals 8. So to undo multiplying by 4, I'm going to divide by 4. What I do to one side, I have to do to the other side. 4 divided by 4 cancels out, leaves me the x. 8 divided by 4 gives me 2. And again, I could plug it in to check. 4 times 2 plus 7 equals 15. 4 times 2 is 8. 8 plus 7 equals 15. 15 is my answer. So it does check out. Okay, let's look at another example, and let's add some negatives into this one. We have 7x plus 10 equals negative 18. As we look at this one, notice that the 7x plus 10, the first thing we want to do is to undo that adding 10. And the inverse of adding 10 is to subtract 10. What we do to one side, we have to do to the other side. That leaves us 7x on the left because those 10s cancel out. They're undoing each other. Then on the right-hand side, we combine our like terms. Negative 18 and a negative 10. The signs are the same, so we're going to add and keep the same sign. Be very careful as you're doing these. If you're putting them in the calculator, be careful that if you see just one sign here, that you're only putting one sign in the calculator. We're not subtracting these. We're saying negative 10. We are subtracting this in the fact that we can write it negative 18 minus 10, or we can add it negative 18 plus a negative 10. That's okay. And that's okay. But you don't see two negatives there. We're not subtracting a negative 10 because we don't see a double negative. That's not okay. Because the signs are the same there. We're going to add the numbers and keep the sign. Because this, the first line here, can be written this way. Then those are the sames, and you can put those in the calculator either way. But that last way that I've marked out is not right. Don't put two negatives where you only see one. Last step on this one is to get the x by itself, and since it's been multiplied by 7, we want to divide by 7. Negative 28 divided by 7 is a negative 4. 7 goes into 28 4 times. A negative divided by a positive is a negative 4. I'll leave the check for you to work. Let's look at another example. negative 3x minus 2 equals 19. In this one, we have negative 3 times x, subtract 2 equals 19. We want to undo the subtraction first by adding 2 to both sides. What we do to one side, we have to do to the other. That cancels, so we're left with 19 plus 2. That gives us 21. On the other side, we're left with the 3x. Be sure that you bring down the negative. Next step, we want to divide by whatever's with the x. Notice when we do that, we don't divide by a positive, we want to divide by a negative 3 because it's a negative 3 that's with the x. And what we do to one side, we always do to the other. It has to be the exact same number here and here because we want those numbers to be exactly the same because it's a number divided by itself that equals 1. And that's our goal here, is to get those to cancel to be 1 and leave us the x by itself. We don't want a negative 1, we want a positive 1, and so it has to be the same sign. A negative divided by a negative gives us a positive. So we need the number to match its sign. So not just a 3, but a negative 3. And what we do to one side has to be the same on the other side. So that has to be a negative down here. And a 21 divided by a negative 3, signs are different, so the answer will be negative. 3 goes into 21 7 times. And again, I'll leave the check for you to work. Okay, let's look at one last example of this type. Negative 5x minus 1 equals negative 6. We have negative 5 times x minus 1 equals negative 6. So to solve this one, we want to move the negative 1 over or undo it. So we're going to do it as its opposite. Opposite of subtracting 1 is to add 1. So we're going to add 1 to the other side, or move that 1 over to the other side is the other way that you can say that. It then gets rid of it, gets its value onto the other side by making it its opposite. Negative 6 plus 1 then becomes negative 5. Then to get the x by itself, again we have to divide by what's with the x, so that'll be a negative 5. Makes that a negative 5 on this side. Any number divided by itself is a positive 1. Leaves me x. And over on the other side, we have negative 5 divided by negative 5, which gives me a positive 1. And then our answer is just x equals 1. And again, I'll leave the check for you to check. And these are a few examples. Now, these have pretty much been all in the same form. I'm hoping to do another lesson with some additional two-step problems. So this will be lesson A. And so if you need some more help, look to lesson B, where we'll do some more two-step equations. But if you're, again, needing more help, you know where to find me in MBSS 222, and come by and see us for some additional help. Thank you.